welcome back. Today it's hopefully it will be a very short video. What I plan to do is establish some of the very basic algebraic properties of vector spaces, which we'll keep using throughout linear algebra. So there are about 5 or 6 facts. Well, let us prove all of them and go through the proof in slower way so that all of you beginners can understand. Okay, yeah. So let me start sharing the screen and start the work. So the first result is, remember, if V is a vector space, okay, then we have an element theta which we call as zero vector. We just call it a zero vector, okay? And what was the property? It had the property that for every x in V, x plus theta is x. Remember, the addition is commutative, so therefore it's also equal to theta plus x. Okay. Now, what we want to say is, suppose V is a vector space, right? Can two such zero vectors exist? What does that mean? Whether there can exist two theta 1 and theta 2 in V, so that x plus theta 1 is x and it's also equal to x plus theta 2. This must be true for every x in V. So I want to say it's unique. Such a theta is unique. What does it mean then? For every x, if x plus theta 1 equal to x plus theta 2, then I want to know whether theta 1 equals theta 2. These are what we want to know. Then I call such a theta is unique. This is known as the uniqueness of the additive identity. Theta is called additive identity. Okay. So this, if you prove this is called uniqueness of additive identity. Okay. Right. You see, if you are learning group theory along with this, you would have known the identity element of the group is unique. It's exactly the same proof. Okay. We will go through that. The first thing I want you to notice is, remember, the vector addition is a map. It's a map from V cross V to V. You understand? Therefore, you call theta 1 and theta 2. Suppose there are two such elements with this property. Let us look at theta 1, theta 2. This will go to a unique element, theta 1 plus theta 2. Do you understand this? This has to be a unique element. Yeah, because what is the definition of a function? Yeah. For each element in the domain, there is a unique element in the codomain. That is the image of the element from the domain. You understand? Okay, therefore this is unique. This is a notation, but remember, this is just a notation. Theta 1 plus theta 2. Okay, you call it as something like this. Then theta 1, the image of the ordered pair theta 1, theta 2 is xi. That's a unique element. Okay, keep this in mind. That fact we are going to use. Many times, in a proof, they will just like that do some jugglery and you will get it. But what the heart of the matter is, you are using the vector addition, or in the group theory, the binary operation is a function. Okay, that fact we are going to use. Let us, okay. So let us do that. Now let's look at theta 1 plus theta 2. Now notice that you said x plus theta is equal to x plus theta 1 equal to x and equal to x plus theta 2. Therefore, consider this as the x and this as theta 2. Therefore, what should it be? This be equal to theta 1. Right? Because it must be x. Do you understand? But on the other hand, that is, I'm assuming theta 2 is the additive identity. Is an additive identity. On the other hand, remember, theta 1 plus theta 2 is same as theta 2 plus theta 1, and hence theta 1 plus theta 2. Now I consider this as x and this as theta 1. This is the additive. This is an additive identity. Therefore, this must be equal to theta 2. You understand this? But what did I say? The order per theta 1, theta 2 goes to a unique element which you denote by theta 1 plus theta 2. But that theta 1 plus theta 2 is theta 1 also equal to theta 2. But this image is unique. Therefore, I claim theta. I conclude theta 1 is theta 2. Please go through the proof. How the function enters the picture is usually not explained in textbooks. Okay. So please go through, review, and then proceed. Okay. Next, we want to prove the uniqueness of the additive inverse. What does that mean? You give me any vector x in V, then I know there exists a vector y in V so that x plus y equal to theta. Anyway, so let's go back. So this additive identity is unique. Therefore, it is you. Okay, we can say the additive identity, that additive identity, because it's unique. Earlier, I simply said theta 2 is an additive identity, theta 1 is an additive identity, and therefore this happens. Now I can simply say, since there's such theta is unique, then I will say the additive identity. Okay, and now come back. So I know the additive identity is unique. Okay, therefore let me ask for given any x, there is a y, so that is a. Now question I'm asking is, can there exist a z in V so that x plus z is also equal to theta? Remember, x plus y is same as y plus x and x plus z is same as z plus x. We don't have to worry about, because commutativity is always true, right? So if this happens, what is that I want to conclude? I want to say this y, this is an additive. This y is called an additive inverse. An additive inverse. For addition, it is inverse operation. It produces zero vector. Okay, x, y, and z are called an additive inverse. Now, what I want to say, they are unique. That means I want to prove y equal to z. Is that clear? Okay. Now, how do I prove that? Yeah. So let us start with this. So I have x plus y, okay, equal to theta, right? Therefore, I can add, okay. So I have x plus y equal to theta. I want to prove y equal to z. Yeah, let me keep that in mind. I keep forgetting. Okay. All right. So what do I do? Can somebody think of? So what do I do? So now let us add z to both sides. If I add z to both sides, what do I get? Z x plus y plus z equal to theta plus z, but this is same as z plus theta, therefore it is z. But this, because of associativity, I can write it as x. So this one I can write as x plus y plus z, the left side. But due to commutativity, this I can write as x plus z plus y. Again, using associativity, I can write it as x plus z plus y. Please follow what I'm doing. Okay, we are using various facts about the properties of vector spaces. Okay, but what is x plus z? That is theta. Therefore, this is theta plus y. But what is theta plus y? It is y. So what did we get? The left side x plus y plus z, we showed it's y. Okay, but x plus y plus z is theta plus z, which is equal to z. Therefore, we got y equal to z. Okay. So please go through the proof. Oh, I wanted to share. I keep forgetting. I'm clicking something wrong. Okay. Yeah. Oh, I wanted to click the next page. Okay. Okay. So we have proved there exists given for every x in V, we have proved there is a unique vector y in V so that x plus y is z. Of course, that's also equal to y plus x equal to theta. Yeah. This y is called the additive inverse. And is usually denoted by minus x. Notice that this is just a notation. Okay. This is one thing we all beginners should understand. This minus y is a notation. This is same thing as saying when I have a real number 2, when I write square root 2, okay, this is just a notation. It stands for a real number x in R whose square is 2, and this x is also non-negative. There is a non-negative real number x so that x squared equal to 2. That x is what we denote by square root 2. This is just a notation. And similarly, when I write y is the additive inverse of x, okay, then I write that y equal to minus x. Minus x is a notation. What does that mean? This means that take this x and you add minus x. See, minus x is a notation for some vector. This equal to theta. This is the meaning, real meaning. Okay. But usually again what we'll do is we will always write it as x minus x. I will come to that in a minute. Therefore, suppose I have two vectors x and y in V, and let minus y be the additive inverse. The additive inverse, right? Additive inverse of y. Then I can add these two vectors x plus minus y. Notice that this is a vector, these two vectors. Usually we will write this vector as x minus y. Okay. That is, we will define x minus y by definition is the addition of these two vectors. Okay. It's just not a symbolic manipulation. Please understand. Okay. This left side we are defining now. Okay. So in the beginning, these are the things you have to learn. Okay. Please pay attention and do that. PRP. Okay. Good. Next, what we want to prove, these are true things. Notice that these two facts are also true if you learn group theory. The identity element of a group is unique and the inverse of any element in a group is unique. The proofs are exactly the same. Okay, right. Except there you will write as multiplicative notation. Here I am writing additive notation. That's the only difference. Anyway, don't worry, if you learn this much, this is okay. Okay. Now let's look at the third result. Third result is, let us look at 0, which is a scalar, and x a vector. Okay. Now I know I can scalar multiply 0 times x. This must be a vector. What I want to claim is this vector is the 0 vector. Do you understand? Again, pay attention. This 0 is a scalar multiple of x by the 0 scalar. That must be a vector. That vector is the 0 vector. Okay. Do not think of your algebraic manipulation of high school. Just like that, I am putting 0 times x is 0. Okay. That's why I am using for the time being a theta notation, so that you don't get confused. Okay. Now I want to prove that. So how will I prove that? Yeah. How will I prove that? So what is theta plus theta? Remember, x plus theta is x. Therefore, theta plus theta must be theta. You understand? Now, what is 0 plus 0? That is 0. These are real numbers, right? Now, remember, one of the properties of vector space is said R plus S times x r x plus sx. R plus s is addition of two scalars and times x, that is a scalar multiple of x by the scalar r plus s. This is scalar multiple of r times x and s times x. This is a vector addition. Make sure you understand all those things. Okay, I want use of this. So I am going to use r equal to 0, s also equal to 0. Therefore, what will I have? 0 plus 0 times x must be equal to 0 times x plus 0 times x. Do you understand? But what is 0 plus 0x? That is 0x. Therefore, 0x equal to 0x plus 0x. This is what I got. Okay, go through slowly. Now what do I do? What is that I want to prove? I want to say 0x equal to theta. Right? So I want theta. How will I get theta? One easy way will be take x, take it in additive inverse, then I will get theta. Right? You understand? That trick I want to use here. So what will I do? So I have here one element, therefore if I add additive inverse of this left side, I'll get on the left side theta. Are you following? That means add the additive inverse of theta dot x to both sides. So what do you think I will get? I will get 0x plus minus theta x. Sorry, not 0, this is 0x, not theta. 0x equal to 0x plus 0x plus minus 0x. You understand this? I am writing very carefully. Now this is 0x, this is additive inverse, therefore this sum is going to be theta. Right? These are two vectors which each is additive inverse of the other, therefore the sum will be the 0 vector theta. Now what do? I can use associativity. When I use associativity, what will I get? 0x plus 0x plus minus 0x. You understand? But what is 0x plus additive inverse of 0x? This is theta. This is 0x. Therefore 0x plus theta. But remember, theta is the additive identity. Therefore what is this? This is 0x. So right side is 0x, left side is theta. Therefore I have proved 0 times any vector, 0, that is 0 multiple of any vector is a 0 vector. Yeah. We proved it. Okay. So again, pause, review, and then proceed. Now let's go to the fourth. So now let us look at the number 1 in R, the scalar 1. Let minus 1 be the additive inverse of 1 in R. Now let x be any vector in B. Then minus 1 times x must be a vector in B. Yeah? Right. Now what is that we want to claim? We want to say minus 1 times x is minus x. What is the meaning of this? Pay attention. Again, because your high school algebra, don't say minus 1 times x is minus x. Minus x, what does it stand for? This stands for the unique additive inverse of x. You understand? Therefore, when I want to say minus 1 times x is equal to minus x, what is that I have to prove? This is what you have to understand. Yeah? So that means I have to prove x plus minus 1 times x, this vector is the 0 vector. That means this is an additive inverse of x, but since I know additive inverse of x is unique, this must be the additive inverse of x, which we denote by minus x. Do you follow that? So this is what I have to prove. Right? Now how do you think I will prove? Again, remember, we are Just now we used r plus s times x is r dot x plus s dot x. So we can, so this x I can write as 1 dot x plus, okay, minus 1 dot x. You understand? This is the second vector. Now this is r times x plus s times x. Therefore this is equal to what? This is equal to 1 plus minus 1 dot x. But 1 plus minus 1 is same as 1 minus 1. What is 1 minus 1? 0. 0 dot x. But what is 0 dot x? We have seen is theta. Alright, just now we proved. Therefore, x plus minus 1 times x is theta. That means minus 1 times x must be the additive inverse, which is minus x. So we proved it. Again, pause, review, proceed. If you are a second year student, this is the first time you are learning, okay, this kind of stuff, please go through each of these 1, 2, 3, 4, go to at least twice, go through these proofs twice at least. If necessary, discuss with your friends. If I would not say if necessary, as a rule, discuss with your friends. Okay, so what have we shown? Something which looks very, very attractive and intuitive. Minus 1 times x is minus x because of our high school algebra. We would like to say that, but it is true here. Okay. Okay. Now, what is the fifth one? Fifth one says we solve 0 times x is theta. Now, what is the other one we would like to say? Suppose alpha, let us say t is a scalar and theta is the unique additive identity. Then I can ask what is t times theta. This is defined, right? This must be a vector in V. I want to know what is t times theta. I'm sure all of you have a guess. It should be, yes, t times theta. I would like to say theta, right? So how do you think I can prove that? Yes. So let us do that. There are many ways of proving this possibly. One way to show this additive identity is this. Okay, let us do that. Okay. So what I want to prove now? So what I do is, remember we used earlier something like r plus s times x equal to something. There is another what I use think of as a distributive law is r times x plus y equal to something, right? So I want to make use of that. Remember, theta is the additive identity. Therefore, theta plus theta is theta. Therefore, what will be t times theta plus theta? This must be equal to t times theta, right? Why they are equal? Again, the same thing, right? That is, the scalar multiplication is a map from r cross b to v. Therefore, I have theta v, t theta, that goes to t times theta. But the theta is same as theta plus theta. Therefore, I can, this will go to t times theta plus theta. Therefore, these two are equal. Because these ordered pairs are the same, therefore their images must be the same under the map. The map is scalar multiplication map. Okay, right. Now this is t times theta plus t times theta equal to t times theta. What do you think I will do? Now you know the trick. I add the additive inverse of t theta to both sides. So what will I get? Minus t theta plus t theta plus t theta equal to minus t theta plus t theta, which is equal to theta because each are additive inverse of other. But this one using associativity, I can put the bracket here and do that. Therefore, this is minus t theta plus t theta plus t theta. but this is 0, sorry, theta plus t theta, therefore it is t theta. So I have shown t theta equal to theta for any scalar t and theta. So again, pause, review, proceed. So this is the last result. You will see that how many times you are using it. Do you see that? Yeah, I'll come to that. So these facts we will be using many times. All these 6 facts we will be using many times without explicitly mentioning in future in the course on linear algebra. So you should learn that. Now what does it say is, suppose alpha is a scalar, let us say t is a scalar and x is a vector. And also assume, okay, this scalar is t dot x, sorry, t dot x equal to 0. Then I want to claim either t is 0 or x is 0 vector. Either this, okay, a scalar multiplied by vector is a 0 vector. That means either the scalar is 0 or the vector is 0. Do you understand? You should always, whenever you see such a result, as I said earlier, you try to formulate your own words. Okay, say it. You may not have said even correctly or very precisely, but it's all right. Keep saying, you will slowly improve. This is part of internalization. Okay, otherwise you can only chant this like mantra. Okay, but this way of interpreting in your own words helps you to understand what is happening. Okay, now whenever I want to prove a result of the form PRQ, this is a statement. Okay, this is one statement, this is one statement. I want to say PRQ is true. Suppose I want to prove this, then one way to prove that will be, when is it true? One of them must be true. So if P is true, then there is nothing to prove, right? Therefore, what we will assume is P is not true. If I want to prove PRQ is true, if P is true, then it's okay. Because PRQ is true, if one of them is true, you said P is true. Therefore, PRQ is true. You follow that. Okay. And suppose P is false. But I want to prove PRQ. This is true statement. So what does it mean? I have to show Q is true. Okay, this is part of our foundation course. Please understand. Right? So t dot x equal to theta, I want to prove this following statement. The statement P is t is 0 and the statement Q is x equal to theta. Therefore, either P or Q is true. Okay. If t is 0, then I am through. Therefore, let us assume t is not equal to 0. Do you understand? Okay. T is not equal to 0, but I know t dot x equal to theta. Since t is not equal to 0, I can multiply this, the multiplicative inverse of t, namely 1 by t or t inverse. Therefore, t inverse of t dot x equal to t inverse of theta. Just now we saw in last one, any scalar multiple of 0 vector is a 0 vector. Therefore, this is theta. But here, I can rewrite this as t inverse times t dot x. But what is t inverse t? That is 1 dot x. The defining property of vector space is 1 dot x is x. Therefore, I have proved x equal to theta. Yeah? If t is not equal to 0, I proved x equal to theta. Is that correct? Okay, good. See, pause, review, and proceed. Now, what I want you to appreciate is, look at that. Do you remember our 8th condition in the definition of vector space is 1 dot x equal to x for all x. This again, because of your high school algebra, you think that should be obvious condition. Okay, that should be obvious. No, we are imposing that condition. Notice that we used it very, very crucially. What are the places we used crucially? For example, here. X I want to write 1 dot x. And again here. Okay, I got 1 dot x on this side. But that's equal to x, and hence I can conclude my x is theta. Do you understand this? Please pay attention. As I said, each of the six things are very important. If this is the first time you are going through this kind of abstract algebraic reasoning, it's worth going through each of the proof at least twice and discuss with your friends. Okay. Hereafter in my lectures, I may write 0 also for theta. Okay, the theta vector, the 0 vector can also be denoted by 0. But you should know what it means. 0 times a vector, or I say that x plus x and y are vectors, that is equal to 0. This stands for not a scalar. This stands for a vector. Here this 0 stands for a scalar. You follow that? So if I write 0 times v1 plus a times v2 plus b times v3 equal to 0. Do you understand what is this 0? This is a scalar. And what is this? This is a scalar multiples. This is a scalar multiple of v2 by the scalar a. This is a scalar multiple of the vector v3 by b. Therefore, this sum of three vectors. Therefore, this will be a vector. This vector equal to 0. That means this 0 must be a 0 vector. Okay. So please get used to that. We will meet again.